Hi guys, good day. Today I'm going to start a new series of videos tackling differential equations according to the IB program for Math Analysis and Approaches, HL. So there are 4 types of differential equations according to this program, IB, MAA, HL. I mean, of course, there are more types. You may see them at the university level. But in this course, IB, MAA, HL, we are looking at 4 types of differential equations. The first type is called the separable differential equation. The second, homogeneous differential equation. The third is called first order linear differential equation. And the fourth approach is called the numerical approach. And basically, we are looking at Euler's method of solving differential equations. Today, the first video, today we are going to look only at the first type, which is separable differential equations. Okay, so bring your pencils if you like, and let's start. Okay, so the first question we can ask ourselves, what is a differential equation? Definition of differential equation is simply an equation which contains derivatives, right? So equation in algebra, as you know, they have left-hand side, have right-hand side, and equal sign in between. So this is called equation. And then if you see any sort of derivative, which is like dy by dx or f prime or y prime or y double prime or f double prime of x, the derivative, of course, we talk a lot about derivative in differential calculus, right? So if you see any sort of derivative in an equation, it is simply a differential equation, okay? Now, the second definition, or the second thing that we need to know, what is ordinary differential equation, ODE. So ODE, ordinary differential equation, that only contains functions which depend on a single variable, which we'll actually see all the way until the end of the course for IB, MAA, HL. So don't worry, you will not see non-ordinary differential equation, just ordinary differential equation, okay? Only single variable, it means f of x, you have only single variable, let's say x, right? Or t, whatever the variable is, it's only single variable. So this is called ordinary differential equation. Now, the second thing we need to, or the third definition, we need to know what we call the order of differential equation. So what is the order? Sometimes you say first order, second order differential equation. It is the highest order of all derivatives in the equation. Now, I have here some examples down here. This is just random differential equations. And we are going only to classify them according to the order, right? So when you look at the first one here, we have dy by dx equal y squared minus x cubed, right? So the highest order here is basically the first order, because we have only dy by dx, which is basically the first derivative, right? So this one here is just basically first order. Is it ordinary? Yes, it is ordinary, because dy by dx is only like by dx, is only single variable. So it is ordinary, but okay, now let's only focus at the order now. So this is basically first order. Now, you look at the second one here, we have dy by dx all to the power of 2 plus x times dy by dx equal 5x squared minus 3. So here, even though this is to the power of 2, but still first order. Why? Because still dy by dx, I only see the first derivative. If it is power of 2, it doesn't affect the order of the derivative or the order of the differential equation. So the second example here is also first order differential equation. Now, And you look at the third example here, d3y by dx cubed, which is the third derivative of y as a function of x. So obviously, this is a third order differential equation. Okay. Don't worry, you will not deal with this in your program. I just want to give you some examples to understand what is the order of differential equation. Now, the last example here, you may tell me, what do you think? What order of this differential equation? Yes, that's right. This is second order differential equation because we see d2y by dx squared, which is the second derivative. So that means this is a second order, or the highest. Sometimes you may see different orders, but I mean the highest order is going to be the order of differential equation. Okay. Now, next, which is really the core of our session today, the separable. The separable differential equation. As I mentioned in the introduction, the separable is one of 4 types of differential equations you need to master basically in this programming. So let's read the definition. A first order differential equation, now you know what is a first order, is only dy by dx, first derivative, or by any variable, it doesn't matter. dh by dt, dg by dz, whatever. That can be split into y terms on one side and x terms on the other side is called separable, right? Now, how do I know a certain differential equation, whether it is separable or not? This is very important. If you can rewrite, that specific differential equation in one of these 2 forms, if you can rewrite dy by dx as a division f of x, a certain function in x, divided by g of y, another function of y, this is separable. Or if you could write as a multiplication. Otherwise, it is not separable. Okay, and this is actually your key to solve the differential equation. You need to know what kind of differential equation we are looking at in order to choose the right approach. Okay, so that's why this is very important. Very important. If you can rewrite the differential equation as a function in x divided by a function of y, or a function of x multiplied by a function of y, this is a separable differential equation. Now let's have a look at this example from Oxford textbook. So we need to solve this. dy by dx equal x multiplied by 1 plus y multiplied by e to the power of x. Now, let's see if I can rewrite this as one of these 2 forms. So let us see. So if I rewrite this as dy by dx, right, on one side, which is already have it, so this is good. We don't need to do like any manipulation on the left-hand side. But then I can just, because they are like multiplication is commutative, of course. So we can rewrite this as x e to the power of x multiplied by 1 plus y, right? I mean, like 1 times 2 times 3 is basically 1 times 3 times 2, or 3 times 2 times 1. The order. You can commute over multiplication. So multiplication is commutative. So now what I can see here, yes, I can see now x times e to the power of x, it's a function in x, or function of x, so f of x. And 1 plus y is a function of y, let's say g of y. So awesome. This is a separable differential equation. And this is your first step in order to solve any differential equations, to know what is the type, what we are looking at. Okay. Now, let me walk you through the example and to show you how to solve this example here. Okay. So the idea here is simple. We can just split the y together with dy, and we can, an x together with dx, right? So maybe I can bring dx here on the right hand side, or you can think, okay, I can multiply both sides by dx, so dx will be gone on the left hand side. So you can say, okay, so dy is going to be x e to the power of x, and then I can put dx here, and then I still have 1 plus y, right? Which also I can bring it down on the left hand side, or you may think, okay, let me divide both sides by 1 plus y, if you like. I mean, which is not really my preferred approach, but I mean, technically you can do that. So you can just cancel, or I always like bring things up or down from one side to another. Or you can say I multiply or divide by specific term, just to to split both of them. So you will end up with dy over 1 plus y equals x e to the power of x dx, which is good. Now we have x dx and we have y dy on each side. And then, of course, the next step here, you're going to put your beautiful integration sign. So we need to integrate. Now, I need, of course, to mention what is the target, what is the meaning of solving differential equation. The meaning is to find a y, or a general solution of y as a function of x. Okay, sometimes we may have conditions or some specific points, but in this example here, we don't have a specific point, so we are going to find y as a function of x using integration. Okay, so when you look at the left-hand side here, we have dy over 1 plus y. I can use inspection. So the denominator here is 1 plus y. The derivative of the numerator is 1 in terms of y, right? I mean, derivative of 1 is 0. Derivative of y is 1, which is actually up here. So if the numerator is the derivative of the denominator, you can just say right away the integration is ln the absolute value of the denominator. Okay, so this is just by inspection. Now, the other side, here we have x times e to the power of x. We have product of two functions, right? In this case, how would you integrate? You can use by parts, okay? So we can use by parts, right? So by parts, you may call, okay, let me just change the color here. So what we do, so we call one function as u and the other function as dv. Okay, I can actually make a video, specific video for integration by parts, but this is not my target today. So yeah, we can discuss by parts later on. But yeah, so what we say, okay, so the integration is going to be uv minus the integration of video. I mean video, I call it video, or so just to remember, video. So what is u here is x. So u is x, sure. And v is going to be the integration of dv. Now dv is e to the power of x. So the integral of e to the power of x is just e to the power of x, right? And then minus the integration of v, which is just, we just found it now, e to the power of x. And then du, if u is x, du is the derivative of x, which is 1, right? So I can say 1 if you want, it's up to you. So 1 dx, right? So now we can rewrite the left-hand side, the right-hand side as x e to the power of x minus the integration of e to the power of x dx. Now this integration is easy. So we can say, okay, so this is x e to the power of x minus, now integration of e to the power of x is just e to the power of x, but then of course I have to add a constant because this is indefinite integral, right? So now at the end of the day, we have ln 1 plus y is equal to that expression on the right-hand side. Now, our target is to find y, okay? Now, I have here 1 plus y inside ln, so I need first to get rid of ln. So how to get rid of ln? Basically, what you can do, you can, raise both sides to e, okay? Because e is going to be like the inverse function of ln, right? So using the property in algebra, right, like f of f minus 1 of x, which is the inverse, is going to be x. So they kind of cancel each other. So e to the power of ln, 1 plus y, it is 1 plus y. So 1 plus y, I mean absolute value if you like, is going to be e to the power of all of this, right? So e to the power of x, e to the power of x minus e to the power of x plus c, right? Now, if you have addition in the powers, okay, like let's say, okay, e to the power, I don't know, of 2 times e to the power of 3. So what we do if you have the same base and you have multiplication, you add the powers, right? So basically this is e to the power of 2 plus 3, right? So I can actually rewrite this as e to the power of x, e to the power of x minus e to the power of x, and then times e to the power of c. So I just replaced plus c up here in the power, as a multiplication, using just the simple power rule. If you have multiplication of the same base, basically you add the power. So then e to the power of c, we can call it another constant if you like. So you can, let's say, let a, capital A, is e to the power of c, right? So then we end up with 1 plus y is equal to e to the power of x times e to the power of x minus e to the power of x, and then times a, let's say, right? And then, okay, I need y only as a, as a function of x. So y, in this case, you can just bring one to the other side with negative sign. So at the end of the day, a times e to the power of x, e to the power of x minus e to the power of x, and then minus 1. And we call this YGS, general solution. And, this is the solution of this separable differential equation. Okay, so the bottom line here is to recognize first it is separable, and then separate the variables, and then integrate using your integration skills, and find y as a function of x. Okay, so by this I conclude my first video today, and see you on further videos. We are going to talk about the other types of differential equations. Okay, have a nice day.